Now let's see what are the different greedy approaches we can apply to the knapsack problem. So we will consider our knapsack with the capacity M. Suppose it is of the 20 kgs, and after that we have the 3 atoms. Every atom has some profit associated with it along with the weight. So the first strategy that we are going to see is what the largest profit strategy. So in this strategy, what we will do is we will always pick up the object with the largest profit. So we will arrange the atoms with the descending order of the profit. So if we will see that here the 25 is the largest profit, so we will take the first atom and we will put into the knapsack. So the weight of the first atom is 18 kg and our capacity is 20, so we can add the whole atom, first atom, to the knapsack. We have left with only the 2 kg capacity is remaining with the knapsack. So if the weight of the object is exceed, so suppose the next weight next atom I will take of the next profit is what, the 24, but its weight is 15 kgs. So we have left with only 2 kgs, so we cannot add the whole atom, second atom, to the knapsack. So whenever the weight of the object exceeds the remaining knapsack capacity, what we will do is we will take the fraction of the object to fill up the knapsack. So we will take the fraction of the second object to fill up the knapsack, so that the weight of the knapsack is 20 kgs. So what we will do? 2 divided by 15. So 2 is, we have left with the knapsack capacity and the total weight is 15 multiplied by 24. So in this way the first atom we have added with what, the 25 profit, and second one we will get the 3.2. So the total profit with this particular set of the atom is 28.2. Let's see the second strategy. In the second strategy, what we are saying that we will pick up the object with the smallest weight. So we are not going to fill the knapsack quickly. So if we will take the second object but the weight of that object exceeds the remaining capacity, we will take again the fraction as the same as the previous one. So here the smallest object, the smallest weight is what, the 10. So we will take this object completely in the knapsack. So therefore this one is completely in the knapsack and the profit is associated is what, the 15. And after that the 10 is left. We have left with what, again the 10 kgs. So what we will do is we will have this 10 divided by what, the 15. So we will add the 2 by 3 multiplied by 24 profit of the second atom. So 15 plus 16. So total profit we will get by using this approach is 31. So which is better approach? This approach is better than the first approach. Now the third approach, greedy approach, we will apply to this knapsack problem is largest profit weight ratio strategy. So what we will do over here is we will always arrange the atom in the ratio of the profit to weight, and it is a descending what you can say, the order. So the ratio of the profit to weight, who is the ratio is what, the greater value is greater, I will always arrange with what, that element first. So in this way we will have the profit weight ratios of all these objects in the descending order. So we have, suppose what, the n elements. So we will have the n elements in the descending order of what, the profit weight ratio. Now we will always pick up the object with the largest profit weight ratio, and if the weight of the object exceeds the remaining knapsack capacity, we will always take again the fraction of that object. So we will, for the same example, we will solve this particular problem with this strategy. So we will have the 25 divided by the 18. So profit versus weight ratio we will calculate for every object. So 1.39 for the first, second is 1.6 and 1.5. So now we will arrange into what, in the descending order of what, the profit to weight ratio. So the first atom is what, the 1.6, which has the highest profit weight ratio. So I will select that atom first. So therefore x2 is equal to what, the 1, and its weight is what, the 15. So I can put that into the knapsack. So I will put the x2 is equal to 1 into the knapsack. After that I have left with what, the 5 kgs to fulfill the capacity of the knapsack. So what I will do, the next profit to weight ratio is what, the 1.5. So I will take the fraction of the third object to fill the remaining capacity of the knapsack. So what I will do over here is, so the 5 and the total weight is what, the 10. So in this way, what, the 5 divided by the 10 multiplied by its profit. So what I will do, I will have only the half one. So what I will do, 7.5. So the profit is also half. So 24 plus 7.5. So I will get the total profit as what, the 31.5. So we can see that it is optimal solution. This strategy is giving us the optimal solution out of the three values what we have built, or out of the three strategies what we have seen. So in the knapsack, for the knapsack problem, we always use this particular greedy strategy to solve this knapsack problem. So this is called as greedy fractional knapsack problem. So the greedy fractional knapsack problem always have this 2 1. So the m is what, the capacity of the knapsack, and n is what, the objects. So we have the two arrays, that is profit array and the weight array. So what we will do is, now we will arrange this profit versus what, the weight array in the descending order, and we have the solution I will represent in the X array. So now what we will do, the first one is, we will initialize our solution vector to the 0. So initially it is empty. After that we will initialize u is equal to m. So that is capacity of what, the knapsack. Now what we will see is, we will take one input, and we will see that whether it is a feasible solution. If it is there, so I can add into what, my optimal solution. So what I will do, I is equal to 1 to n. What I will do, I will check whether my weight is greater than w, so I have to break it. Otherwise, I can take the whole object, and I will minus the weight of that object from the u. So after that, suppose here in the previous example we have taken the which object we have taken, the first one is second object we have taken. After the second object, when my I becomes what, the 2, so I will take the second profit to weight ratio atom. So that time here the weight of the this one is what, the here 15, but we have left with only 5 kgs. So that time this loop is going to break. I will come over here, and that time I will see if my I is what, the less than equal to n. So what I will do is, I will take the fraction of that particular object. So I will take u divided by the weight of I will take only the fraction of that object, so that I will satisfy the constraint on this particular problem. So the total weight is not going to exceed the capacity of the knapsack. So this is the pseudo code for the greedy fractional knapsack. So you can you can take the example, you can see that out of this 3 greedy strategy, you can see that the third strategy is giving you the most optimal solution. So we are going to use this strategy for this particular problem. Now the next thing is, what is the computing time of what, the knapsack problem or the greedy approach. For this knapsack problem, if you will see that this is going to run for what, the n times. Okay, so if we are saying that if we are using some kind of the sorting algorithm, suppose we will use the quick sort, which is a more efficient sorting algorithm, its complexity is big O of n log n, and that for loop is going to run for what, the big O of what, the n times. So this is going to be what, the run into what, the big O of n times. So the total complexity is big O of log n plus what, the big O of n. If I will solve this particular what, the equation, so the total complexity is what, the big O of n log n itself. So for the greedy approach, or the computing time is going to be what, the big O of n log n. So this is all about what, the greedy strategy. So we have seen the examples of the greedy strategy, how we can apply the greedy strategy to solve that examples. For any query, please you can write down to me, psvidep@pict.edu. Thank you, students.